Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the proximity sensor to PLC Omron model CP1E by using the two types of proximity sensor. The first type is PNP type and the second type is NPN type. And here is the PLC, it is the real PLC, and here is the drawing that I draw for easy to understand for this wiring. So first I have circuit breaker and I have power supply, input 220 and output 24 volt DC, and I connect the power 220 to the PLC for supply, and I will use the program CX-Programmer version 9.7 to create the sample project and then download to the PLC by using the USB cable. Okay, and I will explain to easy for understand about how to wiring the proximity. So for PNP, we already learned in the previous video. So we supply the 24 voltage to brown and blue color of the cable, and then the black cable will generate the plus, yes, generate the voltage positive to relay control. And for NPN, we can connect positive voltage to brown and also connect with the relay, yes, magnetics of relay, and it will generate negative volt to magnetic relay. Okay, so we can follow my drawing to connect this wiring. Actually, if we purchase the proximity sensor, mostly it already draw like this. Yeah, example the NPN, it will connect minus to directly to proximity sensor like this, and plus or positive we also connect to brown, yes, here, and we connect jumping the positive voltage to the coil of relay, yes, so it will work. And I will use nominal open of relay and then connect to the digital input of PLC. For NPN, I connect to input number 0, and PNP I connect to input number 1. Okay, and for the output side, it will start from 100. It means that Q100.0 I connect to one relay, and another output 100.1 I connect to another relays. Okay, so this is a detail about how to wiring the sample wiring of proximity sensor to the Omron CP1E of input and output. Okay, so let's go to our program to create the new project and then test with the real PLC. Yes, and then we will create the sample program for control. Example, control the actuator or control forward and reverse. We can take signal the proximity sensor to cut off the it means that the same as limit switch. Yes, I will detail when we write the program. So first we need to test the input and output from the proximity sensor to the relay, and then check the input on the CX-Programmer software. Okay, so let's go. Okay, so first let's open the CX-Programmer. Yes, I already installed in my PC. Mostly we can use this tool software for create the program on the PLC and CX-Designer. We can create the project and then download to the HMI. And also we can simulation between CX-Programmer and CX-Designer together. Okay, I already show on the previous video. And for this section we can also simulation. Yes, so first let's open CX-Programmer project, and then we can create a new project. Example, proximity sensor, and we need to choose the device type to match with the hardware. It means that to match with the PLC hardware. So our PLC is CP1E and type E20. Yes, so we can choose CP1E and go to setting. It has many CPU type that we can use. For me, I will use E20 because we use the hardware E20, and we can communication by using the USB cable. Yes, and this is a driver. Yes, so we can command as connect proximity sensor to PLC Omron CP1E-20. Yes. Okay, we will got the new project, and this one we can rename the program. Example, I rename as proximity sensor. Yes, so it will come to section name is proximity sensor. Okay, so if we have another section, we can also insert the section. Yes, we can insert the section. Yeah, here example, I add one more section. Example, forward and reverse. Program reverse logic. Yes. Okay, we will got two sections. One section is proximity sensor signal. I will rename as signal. Yes, and the section 2 is forward reverse logic. Okay, so we can go to test with the proximity sensor signal. Yes, so before go to create the program, we need to check the communication of PLC and PC first. Okay, so right now I will insert the USB cable from my PLC to my PC. Okay, I will use Visual Machine. Yes, and then if the driver is installed properly, we can go to check. Right click on my computer or this PC, go to manage. We can check, yeah, and then go to device manager, and then we can go to universal serial bus controllers Omron Sigma PLC device. So if I disconnect the USB cable from my my PLC, it will hidden, right? I connect again, it will come again, and we can see Omron Sigma PLC device. Okay, so this is how to check the communication between USB cable and computer before we create the program. Okay, so let's go to our program, and then we can go online, work online to check the communication. Yes, okay, right now we can communication between our PC to the PLC. Let's see, here is the status of PLC is run mode and the program is running. Yes, so we can offline first, and then we test the proximity sensor, right? So the first step, we need to check the input 0.0 and 0.1. For 0.0 I connect from NPN, and 0.1 I connect from PNP. Okay, so first we can go to create the input, example 0.0, right? Example NPN proximity sensor. Yes, NPN proximity. Okay, and I will turn on the output, example W0.0 output NPN. Yes, okay, and we can zoom Alt and then arrow key, we can zoom. Yes, and for input of PNP, we can also insert the NO contact, and then I0.1, right? So this one should be PNP proximity. Yes, and I will insert one more output, internal memory working area W0.1 output PNP. Yes, PNP, it means that we can get the signal positive to from the proximity sensor and send to the relay control, right? So we can connect. Okay, and then we can test with the real PLC by save the project. Okay, I will save to keep on desktop and then create a new folder. This one should be CP1E proximity sensors. Okay, and then proximity sensors, and then we can go online and then download the project to the PLC, right, for test the signal. So I will transfer, go to PLC and then go to transfer and then to PLC. We transfer all, yes. So transfer all and then yes to transfer and confirm. If we confirm, the PLC will stop, right? So yes to confirm. PLC will stop mode. Let's see here and then click OK and then confirm to run, yes, to run mode. Okay, let's see here, the PLC is run mode and the section of program is running. Okay, so we can test the signal. So let's test with me. Okay, so first we need to test the signal. So NPN type, yeah, I connect to I0.0, yes. If I detect the proximity sensor, let's see I0.0 is turned on, yes. And one more time, PNP, I connect to input 0.1. Let's see 0.1 is turned on, yes. And if I type together, yeah, let's see here, it will turn on together. Okay, so input from proximity sensor is working properly, yes. So we have the signal, right, from the proximity sensor number 1 and number 2, and then we can create the sample program to start and stop for forward and reverse, yes. So I will outline first, and then we can go to section forward and reverse logic. Example, I have start forward, stop forward, and limit switch for cut the signal, right? Because if we have the damper or actuator, we can start forward and reverse and then cut by limit switch, right? Okay, so first let's go to start, sorry, stop. I will stop like this. I will use I 0.2, sorry, 0.4 is stop, right? Because right now I connect from push button start and start forward and reverse with I 0.2 and I 0.3. So I will use I 0.4 is stop all, 0.4, stop, stop all. And we need to start forward, right? Okay, so example, I will use start forward. Sorry, 0.2 start forward, start FW in mean that start forward, and then I will use Q 100.0 is command start forward. Example, output forward CMD, because the Omron will start from 100.0 for output for this type CP1E. Yes, so we will start from 100.0. Okay, and then I will connect like this first. Okay, and I will hold the signal when I start forward. So hold by 100.0. Okay, we can write step by step like this. And we need the limit switch for cut, right? So I will use the limit switch. So I will use NC. So for NC we can use from this section. We can use this one or this one. Example, I will use W0.0 is limit switch for cut the signal forward. Yes. Okay, so I can use W0.0. Yes. Okay. And then we need to stop before start reverse, right? So I will insert one more start reverse. Example 0.2, 0.3, right? Start reverse. Okay. And then I will use one more output. So 100.1 output reverse CMD. And then we can connect the wire. Yes. And I will hold the signal by using the 100.1. Yes. And then we can connect the wire. Yes. And then we need to cut the signal when the limit is show the position, reverse position, right? So I will use NC. And then we can use W0.1. It is the output PNP, proximity sensor. Yes. And then we need to put the interlock between 100.0 and 100.01, right? Because we cannot allow the output is working together. So we need to put the interlock. Example 100.1. Yes. And this one should be 100.0. Yes. It is the interlock contact. So here we can push stop from the push button, right? But right now I have only two push button, forward and reverse. So I will put internal memory, yes, for easy to stop. So example, I will use NC and W0.2. Yes, because 0.0 and 0.1 we already use, right? So example, stop reverse, stop forward. And one more example, W0.3, stop reverse. Okay. So when we start forward and then the proximity sensor, yeah, the position is until forward position, the motor will stop by using the proximity sensor for cut, or we can stop from the touch panel or HMI, right? So save the project and then we can download the program to the PLC, and then we can go to PLC and then go to transfer to PLC, yes, transfer all, yes, yes again to confirm, stop the CPU, and program is downloading and finish, and we can run the CPU back and the program will online like this, yes, okay. So I0.2 is start forward, right? I0.3 is start reverse, and proximity sensor will cut, right? So let's test together. Yes, let's test together with me. So I will test the button first, it work or not. Okay, it work. So I can stop by push the proximity sensor. Okay, I will put like this, easy to see, yes. Okay, so let's test together. So right now I will push start forward. This one example is pull button start forward. Okay, I will push. Let's see, I0.2 is turned on, and then the output is turned on also. Let's see, the signal output is turned on and the relay is turned on also, forward. And we need to stop. We can stop from HMI, or we can example it the motor will drive to the position until forward, it will cut by proximity sensor, yes. So the motor will stop, and if we would like to start reverse, we can push here, yes. Let's see, the output is turned on and the relay reverse is on, and if we would like to cut the signal, we can cut by touch with the proximity sensor, yes. So I will touch the proximity sensor, yes. So the signal will touch and cut the motor, okay. And we can start again, yeah, it will run again. And if we would like to stop, we can stop here, yeah, stop from the HMI. Example, I write stop, yes, it will stop the relay, yeah, I write back to 0, and we can start the by push the button start reverse, yes, the reverse is start, and then we can also stop from the HMI. Example, I push this one to 1, it will stop, okay, I back to 0. And if we would like to start the motor forward and reverse from the HMI, we can also add more internal memory. Example, I will insert like this. So we can insert the rung, right? Insert the row, yes. And then here we can put push button start from the HMI. Example W0.3 start forward from HMI, yes. And then we can connect, and we can simulation to see the status together. Yes, and I will insert one more for row. Yes, insert row here and use the W0.5, right? So this one should be start, reverse, HMI. Yes, then we can connect here. Yes, and save the project, and then we can go to set up the HMI, right? HMI project, and then we can simulation from the HMI. Yes, so let's go to open CX-Programmer, CX-Designer for designer the HMI, and then we can simulation together. Okay, let's insert the new project. I will use NS10 V2. Yes, version I will take the last version. So the title program example proximity sensors and we can browse to find the folder that we already created on desktop and go to communication setting. Okay, and I will use serial A for communication between PLC and HMI, and the type is Sigma PLC. Yes, and the protocol is NT and 1 to N. Yes. Okay, and then I will create the screen one. Okay, we will got screen like this. So we need to create the push button start forward, start revert, and stop forward, right? Stop revert. Yes, or we can insert one more column for stop all, right? Example, we can stop all from here. Because we need to stop before we run reverse or forward, right? So I can put the stop here. So I will insert the column. Okay, and then I will Control X. Okay, W0.2. I will use the W0.2 is stop all, so no need to have this one, and this one also no need. So I will rename this one as stop all HMI. Yes, stop all from HMI. Okay, so we need to create the button start forward, button start reverse, and stop from HMI, right? So let's go to create here. So I will use bit button right here, on off button. So example stop all. So stop all is W0.2, right? So we can go to choose the type. It's so small, right? I will increase the size a little bit. So go to text and then okay, like this, stop all. The label is stop all and then the color I will change to red. Yes. Okay, stop all like this. And we need to have the button start forward. Start forward. Yes. Start forward and start reverse, right? So we can copy here. Start reverse. Yes, like this. And we can align. Okay. So this one I will change color to be blue color. Cannot see, right? Maybe I will change to yellow color. And this one should be yellow color also. Okay. So we have start reverse, stop all and start forward, right? Okay. And then we need to have the signal command forward, command reverse, right? So I will use bit lamp. So example, this one will show the signal. Cycle like this. Yes. Example, when the output is turned on, it will show as start forward and reverse, right? So I will insert the label. Okay, label here. Go to label, yes. Okay, so we can use the label. Example, this one running forward. Actually, we can design the style that we want. Yes. I will not use the background, but the text I will use green color. Example, this one is run forward. Yes. And I will copy for run backward or run reverse, right? Okay. So we can configure the button. Example for button stop. Button stop is address W0.02, right? So go to momentary and then go to address and working area. Yes, work area W0.02, right? And for the start forward is W0.4, 0.04, right? So working area 0.04. Yes. And for reverse start, it will start from W0.05, right? So I will change this one 0.05. Yes. And for the forward signal running, right, is 100. So we can use 100. Yes. And for backward is 100.01. Yes. So 100.01. Okay. So we can copy here example start and stop, start forward and reverse from HMI. Yes. And then we can increase the size. Also big, right? So we can adjust like this. And for the color I will change to yellow. Okay. And then we can save the project, and then we can close the CX-Programmer, and then we can test simulation. Okay, connect to CX simulator and browse the file that we would like to simulation. So we can go to CPE proximity sensor and then open the project file and then click start to start the project. It will simulation. Yes. Run simulation. Okay. So waiting for screen start up. Yes. And then we can put like this. maybe I will zoom out a little bit, Alt and then a row key for easy to see the signal. Yes. Okay. And then we can push start forward. Example, I push start forward. Yes. The motor will run forward and the output is turned on. Yes. And then I will stop all. Yeah, stop all. And then I will run reverse. If the motor will run reverse, it's running reverse, we cannot push start forward, right? Because we use the interlocking, yeah, for this one, interlocking between this one and this one. Yes. So we need to stop first and then we can start forward, right? Yes. So that's correct. So thank you very much for watching my video. This is just sample program about how to use the proximity sensor, how to wiring, and how to create the sample project for test with the forward and reverse, yes, signal. And I hope this video just example. It is just basic for everyone that would like to use the CX-Programmer and CX-Designer for simulation. And I'm also sorry if I have mistake in this video, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.